Hi, I'm Tony Northrup for TrainSignal, and in this video lesson, we're going to learn how to configure remote connections for Windows 8. This lesson maps to the Microsoft Certification Exam 70-687, Configuring Windows 8. This is Objective 5.1, and it has 5 different sub-objectives. The first is Configure Remote Authentication, which doesn't really belong in this exam. The second is Configure Remote Desktop Settings, and you're going to get off a little easy because I've covered that in a different lesson, so I won't be covering it here. The third is Establish VPN Connections and Authentication. Not so easy here. We are going to set up a VPN connection and test it. I'll show you how to do it through both local computer settings and group policy settings. Next, we'll establish VPN Reconnect. And finally, we'll cover how to manage broadband connections. Here I've made a slide demonstrating what a VPN is. At high level, a VPN allows a computer to connect to internal resources across the internet. VPN is literally a virtual private network. And I'll tell you a story about the olden days when I was working at a company called BBN. We were one of the companies that helped develop VPN technology, and we were one of the first to sell it to corporations. Well, at the time, 98, 99, 2000, the way that companies connected their branch offices so they could share files and email and such was through these hardwired connections. Things like ISDN connections, T1 connections, T3 connections. To put this in perspective, the ISDN lines were 128 kilobit connections, and they cost $250 a month or so. The T1 connections were about 1.4 megabits, and they cost over $1,000 a month. And the T3 connections were 45 megabits, and they were tens of thousands of dollars a month. And that's how much it cost to connect a branch office to a central office for networking. And my company, BBN, well, we were in charge of running circuits. We were basically what they call a telco, a telephone company. And we would physically run these cables to the different offices and then link them up through a network. But every connection between the offices was this dedicated line. So you had this amount of bandwidth whether you used it or not. There was literally copper, a pair of wires running from a branch office to your corporate office. And that was how things were done for decades, up until the late 90s when virtual private networks started to become popular. What a virtual private network does is it simulates that private connection, but it does it across the internet infrastructure rather than what they call the public switched telephone network, the PSTN. So the internet, of course, especially if you put your head into the space it was in the 90s when the internet was still emerging, the internet was like a scary place. It was like no man's land. It was where people went when they didn't want to be in the real world. And people were getting hacked all over the place. There was just worms and viruses everywhere. Security was way worse than iffy. Like, stuff was just getting compromised 24/7. So my company, Bolt, Beranek, and Newman, we helped to develop these VPNs. And it was a crazy sales pitch, and we literally had people laughing us out of the room at first. We said, we'll get rid of your $10,000 private internet connection, and we'll give you a high-speed internet connection, and you can use it to get to the internet. And we'll hook up these VPN boxes, and you can use them to connect your different offices. And it will cost you, a tenth of what you're spending now. All you have to do is send all your private corporate communications across the public internet. And people would scoff at us because the public internet, again, it was a scary place, and you didn't want your corporate stuff on the public internet. They were sure it was going to get hacked. Well, fast forward to today, and these private connections are essentially gone. A few government agencies will still use them, not even because they want to, but because of regulatory requirements. Everybody trusts VPN security without a second thought. Granted, security has improved in some ways, but for the most part, we're using the exact same protocols and systems that we used in the 90s, and it's still working just as well because it's always been okay. So this is a diagram of how a VPN works, and the example I gave of VPNs was connecting a branch office to a corporate office. However, VPNs are also used to connect an individual client to a corporate office. Basically, your computer at home becomes a branch office, and you connect seamlessly to your internal network. So if you're not familiar with it, well, most companies on their internal network, they have resources that aren't on the internet. They probably have file servers, for example. And you can only access these file servers when you're connected to the internal network. So when you're sitting at your desk, you just connect to the files and you edit them fine. When you go home, well, you can't get to them over the internet. People don't want to put that stuff on the internet. All you have to do, you fire up your VPN client. It makes a tunnel across the internet. It connects to the VPN server, and it encrypts everything. It secures the client and the server, so they both are trusted. And then every bit of data that goes to this internal network over here travels across this virtual private network. If somebody on the internet here, like if somebody goes into your ISP's physical facilities and listens to the network communications, all they'll see is random bits of data. Well, they're not random, they're encrypted. But without a decryption key, they wouldn't be able to access it. So the VPN client and VPN server here, they establish secure communications that are encrypted and can't be intercepted. So you can trust all these communications going across the internet. So that's what a VPN is for and how it works. Basically, it saves you from running a really long network cable between your computer at home and your work office. It just uses the internet as the backbone for all communications. I'll talk about one of the downsides now. I've drawn two separate lines on this, and the green line here is all internal communications. If you're accessing a file server that's on your internet, that's the way it would go. It would go from your VPN client across the internet and through the VPN server. The VPN server has a connection to both the internet and the intranet, and it just forwards communications to the intranet. No problem at all. So here's the catch. When you're browsing Facebook, the communications go across the internet to the VPN server, and then the VPN server looks at the communications and maybe it has some firewall rules where it blocks something, but if it decides to let the communications through, well, they then go back to the internet. Then when Facebook replies with your friends' boring status updates, they come back through the internet to the VPN server and then back across the internet to the VPN client. So what we see here is we see a much longer than normal leg of communications. Instead of going directly from the VPN client to the internet servers, they go through the VPN server. And basically what you see is at least twice the latency, because the packets have to travel twice as far. They have to be processed here. So you end up with a much greater physical distance and a much longer latency. Latency is the measurement of the delay of internet communications, and you'll see it when you're browsing the web. Stuff will just take longer to appear, and God forbid you try to play a game or something that happens in real time. You try to stream video, it's going to end up being really frustrating. So one of the downsides to VPNs is they always have increased latency, just necessarily. And this can be exacerbated if the VPN server isn't close to you. So imagine this scenario. You work at an international company and you work out of the Boston office. Well, you travel to the company's Japanese office and connect to a public hotspot there. Now, you have a VPN connection set up that goes to your Boston office's VPN server. But what you need to do is you need to access a file on the Japanese server. Now, you might think that your communications would go from your hotspot in Japan directly to the Japanese office, but that's not the case. For VPN servers in Boston, your communications are going to go across the ocean into Boston and then back across the ocean to Japan. And then every reply packet needs to go back that same distance. So every single packet is literally circumventing the world, both on the trip there and the return trip. And that's going to mean everything is going to be slow. Just a little sidebar, but network communications happen a little bit less than the speed of light. And the speed of light seems really fast, but when you're talking about circumventing the globe, it's not that fast. So you can end up with latency of more than a second in a scenario like that. So it's really important to have multiple VPN servers available in different locations and to always pick the VPN server that's closest to where you are. Here's a slightly different but less common architecture. It's the VPN with a split tunnel. Now, the tunnel is the term that they use to describe the VPN communications between the VPN client and the VPN server. This is a tunnel here. With a split tunnel configuration, you're basically making a second tunnel. This way, if the client goes to access resources that are on the internet, they don't have to be bounced off this VPN server and add all that extra latency. So if your network administrators create a VPN and they enable split tunneling, what will happen is that the internet will suddenly become much more usable to people who are connected to your VPN. I think it's a good idea. Now, the challenge here is a potential security risk. And like everything, security, it's a compromise between security and convenience, right? So clearly the split tunnel configuration provides much greater convenience because the internet is going to be faster. However, it also presents some greater security risk. At this point, the client computer has connections open to both the internet and the internal network. So imagine that there's an attacker on the internet who's able to compromise the VPN client. Once compromised, it will actually be able to get to the intranet. Now, back in the old days of Windows XP, Windows had some security vulnerabilities that made that really, really easy. Somebody from the internet could just send a specially formed packet and it would get right through there. Now, that's not the case anymore. That's long since been patched. They make sure that this computer won't do routing across VPN connections, at least by default. So the vulnerabilities are still reduced. But that's not to say that something on the internet can't get an agent running on this computer and immediately get through to the intranet. It would take a higher level application such as malware to accomplish that, though. So I just wanted to contrast a traditional VPN architecture where everything travels through the VPN server and a great deal of latency is added for internet access, with the more up-and-coming split tunnel configuration where only private traffic is tunneled across the VPN and all public internet traffic is sent directly to the internet servers. So with those concepts down, let's look at a real-world scenario. You've been working on a document at work on a file server, and you need to be able to continue your work at home. It wouldn't make sense for you just to copy it to a flash drive because other people are working on the document at the same time. You're performing some collaboration here. So instead of removing the file from the network, you need to connect back to your internal network. You talk to the network guys and they give you the IP address of their VPN server and tell you that you can connect to it from your home PC. So let's do that now. So here we are on the Windows 8 desktop, and like most things, I'm going to initiate a VPN connection by searching for the right tool. I'm searching the start screen for VPN and then switching to search the settings. Over here, I'll click set up a virtual private network connection. Pretty straightforward, right? Now it asks me for a internet address, and then I just get to name it. Pretty straightforward. The network guys actually gave me a list of different VPN servers that I can connect to. Now the network guys understand that latency is a real issue with VPNs and that it's important for a VPN server to be geographically located near you. So I need to look at this list and pick the one that's closest to me. If I'm not entirely sure, here's a trick I'll show you. I'm going to open up a command prompt. And we're going to use the ping tool to get a rough measurement of the latency between me and different VPN servers. So I'll ping that first one. So you can see here I have a latency of between 95 and 98 milliseconds. That's not too bad. I'll ping the second one now. Oh, good. So the second one is actually much faster. That's 44 milliseconds. Let's see how that third one does. Okay, a little slower, but it looks like this second one is going to be the quickest one. Now, Hong Kong is probably the farthest away, so just for kicks, let's see how long that one takes. Just typed it. Okay, so see the difference here. The closest one had a latency of between 36 and 44 milliseconds. A millisecond is 1,000th of a second. Over here in Hong Kong, which is on the other side of the world from me, the latency is about 1/4 of a second. Now that's a measurement of the time it takes for a packet to get to the VPN and back. So everything I do would be delayed at least 1/4 of a second. But think about this, if I'm going through the VPN and connecting to a server on the internet, well, I have to add up both my latency to the VPN and then the latency of the VPN to that internet server. And it's really easy to get that latency to be over a second, and things are going to be really, really slow. Well, we decided this second one had the lowest latency. So I'll copy that to the clipboard. And then over in the Create a VPN Connection wizard here, I'll put it in as the internet address. Now you see a couple of options here. Use a smart card. I would use that if my company required me to use a smart card, but they don't, so I won't check that. And of course, remember my credentials. That just means you don't have to type your username and password every time you connect. So I'll click Create to create the connection. So this creates the connection, and now you can now see it listed under Networks. It does not, however, establish the connection. I don't know what that icon means, but I'll click this, and now you can see I can click Connect. It works just like if there were a Wi-Fi network that was available, but you hadn't connected to it. So click Connect now, and it prompts me for a username and password. So I'll put the credentials in that my network administrator has given me. And then I'll click OK. So what we see now is the VPN connection is connected, and you can see something interesting here. The network is indicated as limited. Now, limited means that I can access resources only on my local network, but I can't access internet resources through this connection. This indicates that the VPN is configured traditionally, meaning all internet connections are going to go through this VPN, not just limited connections going to the internal network on the other side of the VPN. In other words, this is not a split tunnel, and I can tell it because my local network here is limited. For all internet connections, they're going to go through the VPN connection here. Disconnecting it is this easy. So I'm going to open up a web browser here, and I'm going to visit my favorite website for determining what my IP address is, and that's IPChicken. I don't know why, it's just the one I remember, but it works, ipchicken.com. You can see my current IP address is 209.99.2.43. So what I'll do now is I will disconnect my VPN. And you can see the network status. My local network here went from limited to connected, and this is no longer connected. So I will open up another tab and visit IPChicken with it. And you can see my new IP address is 208.103.76.57. My IP address changed because when I was connected to the VPN, my IP address changed because while I was connected to the VPN is communicating on the internet for me. So the IP address that I see is that of the VPN. When I'm not connected to the VPN, I see my own actual IP address. That's my real IP address. You can see here on the Metrocast network. So that's how you configure a VPN connection from the client. And that's really straightforward. But now I'd like to jump over to a Windows Server 2012 computer and show you a little bit about configuring it in an enterprise. So this is a computer running Windows Server 2012, and you can see I've opened up the Active Directory Users and Computers tool here. Now you won't be expected to know that for this exam because this exam covers Windows 8. But I did want to show you one aspect of configuring user accounts here. So I'll open up my own user account and I'll select the Dial In tab here. Now, I talked earlier about how before VPNs we used these physical hardwired connections across the public service telephone network. And that's how we did branch offices to corporate offices. Well, if you wanted to get to your office's network from home, you used a modem, which are these screechy things that are incredibly slow, and basically you had to plug your computer using a phone cable into your phone line, like your home phone line, and it would take up your phone line and it would make all this noise, and the communications would come through, I don't even know in kilobits, but it would probably be about 24 kilobits, 28 kilobits, really unbearably slow speeds. Anyway, That was called a dial-in connection, and that's why today this tab here is still called dial-in, even though most people aren't going to be using it for actual dial-in with a modem. Instead, it now relates to using a virtual private network. So you see some important settings here. The first is the network access permission, and this controls whether this user is allowed to dial in with a VPN. So you see three different settings here. By default, it's set to control access through NPS network policy. So NPS network policy is a service that you can configure in your Active Directory domain on Windows Server 2012 or earlier versions of Windows Server. And you configure these policies to decide which users are allowed to dial in, from which locations, and what times of day, and what user accounts, etc. It gives you all this control, and you don't have to know it for this certification exam that's covered in more complex exams. But you see two other options here. If I select deny access, then this user could never dial in or connect using a VPN either. And if I select allow access, then this user will just always get access to the VPN. So different versions of Windows Server show this differently. But what I want you to know is that you often need to go in and enable a user's account on the dial-in tab of their user properties before they can connect to a virtual private network. So with that done, I want to show you how to configure a VPN using group policy. And I will go into the start menu here and pull up the group policy management tool. And this is the default domain policy, so I'm going to edit that. This is the group policy object that applies settings to every computer in the organization. And you'll see that it mostly looks exactly like the local group policy that we work with in Windows 8. In fact, I can expand this here and you'll see the exact same settings, but that's not what I'm doing right now. Right now I'm going into the preferences. Preferences basically just set defaults for users. Users can later change them, but it's a good way to set up a user's computer ahead of time. And you can use this to configure default VPN connections for all your users. So if you're deploying a bunch of Windows 8 client computers, you don't want to have to go to everybody's computer and type in the name of your VPN server, and you don't want to have to email them instructions to do it. All you have to do is to go into your GPO and select network options here and then configure a network for them. So I'm just right clicking it and I'll click new and then I'll click VPN connection. You can see they still allow you to make dial-up connections because I guess they're not going to pull it out. And here I just configure the exact same things. I can name this VPN connection. And well, this is how old it is. This dialog box has not been updated in forever. They're prompting you for an IP address. I don't know why that is. By default, they want you to type an IP address, but nobody uses IP addresses anymore. We pretty much use DNS names. So I'll select use a DNS name here, and then put in the name of the VPN, whatever it is. This first connect group here allows you to first establish a dial-up connection. So you could dial into a local internet service provider using your modem, and from there establish a VPN connection. I can't imagine how slow a dial-up with a VPN would be. It would be slow. Anyway, this is really all you need to do to configure a new VPN. You can see there are different options here for updating or replacing it, but we'll just create a VPN connection. So now whenever clients applied this group policy, probably the next time they restarted, when the user logged on, they would see this as an option to connect to automatically without having to go in and type the name of the VPN. The sub-objectives for this objective want you to know remote authentication. And look, I've written about 20 books for the Microsoft certification exams, and I've passed more than 30 of the certification exams, and I've written tests for many of the different exams and worked really closely with the exam makers. And so I know the certification process really well, and I'll tell you kind of a secret. They have real flaws in the way that they come up with the objectives. First, they can't ever change the objectives once they decide on it. And if you think about it, that's not really how a software company works, right? Software companies make mistakes all the time. They put out software with thousands and thousands of bugs. They don't care because they can fix it later. So they have this kind of philosophy where we'll get it as good as we can for now by the time it's due, and then we'll put it out and we'll fix it later. Well, the problem when it comes to making these certification exam objectives is that they're legally not allowed to change them. So they release them, and sometimes they have bugs in them. They have mistakes in them. And then they're stuck with them just for the life of the exam. They'll replace the exam at some point. So I think this is one of those mistakes. I think whoever came up with the exam objective didn't understand that the clients don't have anything to do with remote authentication. Remote authentication is an important part of configuring a VPN from a server, but this exam covers configuring the Windows 8 client, and there's nothing to do. I showed you exactly how to configure a VPN, and you can see we didn't configure any settings for remote authentication. But here's what remote authentication is for your reference, and so I feel like I've covered all the different sub-objectives. VPN server can be many different things. Sometimes a VPN server is a server running Windows Server 2012, and it might even be a domain controller as well. More often, a VPN server looks something like this. It's a piece of network hardware that goes into a rack, and it connects to your internet, and it connects to your internal network. And the VPN server, you can get these cheap. You can get some of them for $50, $100 for something for an enterprise, $150, and they can handle thousands of connections. So most of the time, a VPN server is this piece of dedicated network hardware, maybe something made by Cisco, that is optimized for network communications. It's lean and it's cheap, and it doesn't run anything like Windows, and it doesn't have a GUI on it. It's managed using management tools. So it doesn't know anything about Active Directory domain controllers. So over here, the Active Directory domain controller, that's how you log in. When you type a username and password, this guy knows whether you type the right password or not, and nobody else does. That's one of the roles of the Active Directory domain controllers. So over here at the VPN client, they want to be able to log in with their Active Directory domain controller credentials, right? Well, the VPN server, it doesn't know how to talk to a domain controller directly, because this Kerberos protocol that domain controllers use, well, VPN servers don't talk that language. They talk a language called Radius. Radius is just a very decades old authentication standard. It's been around forever. It's super simple. It comes from back in the days when we used dial-in modems, and like I said, VPNs evolved directly from these modems, and as a result they still use all the same standards, including Radius. So when you dialed into a modem bank, you'd have all these modems, and to determine whether or not the user was allowed to connect, it would send a Radius request to the Radius server, and the Radius server would usually make a decision, because the Radius server probably had a list of users. Well, nowadays, we don't want to maintain a list of users over here on the Radius server and a separate list of users in our domain controller. So what we have are Radius servers that know how to talk to the domain controller. And Windows Server has a Radius server built into it for free. So you can set up a Windows Server 2012 computer as a Radius server, configure it to talk to the domain controller, and then configure your VPN servers and your modem banks, if you still have them, to all talk to the Radius server. So think of the Radius server as the translator between your VPN servers, your wireless access points, and your modems, and your Active Directory domain controller. Basically, the Radius server allows you to authenticate to these very dumb devices using your state-of-the-art single sign-on Active Directory domain. Now, I was telling you a little bit about how sometimes exam objectives have stuff in them that's not in any way relevant to the exam. Sometimes the opposite is true. Sometimes the people making the exam completely forget something that's really important. Here's something that I think is important that's not technically on the exam objectives. It's called direct access. Direct access is just like a VPN, except that you don't have to manually connect to it. I kind of showed you how to connect to the network, and it required a couple of clicks, and sometimes you have to type a username and password, sometimes you have to put a smart card in. Well, the way direct access works is it detects anytime the client computer has internet access, and it establishes this VPN-like connection, a direct access connection, back to the internal network. By default, direct access uses a split tunnel configuration, so it doesn't slow down the user's internet connection. It just allows them to access internal resources whenever they want. Of course, it's encrypted and authenticated. Now, in Windows Server 2008 and Windows 7, direct access was designed around an IPv6 infrastructure. IPv6 is this updated version of IPv4, and it's great. It fixes a ton of serious problems in IPv4. However, nobody really uses it. Most organizations aren't up and running on this latest version of IP. It requires upgrading almost all of your network infrastructure and many of your clients and servers, and it just hasn't been really widely adopted. So because direct access required IPv6, direct access was not widely adopted, and people just kept using VPNs. Well, I want you to be aware of this improvement for direct access in Windows 8 and Windows Server 2012, because those two are kind of the same thing. They made direct access much easier to deploy, so you no longer need an IPv6 infrastructure. In fact, if you are using all Windows 8 clients and Windows Server 2012 servers, you can set up direct access in 3 clicks. That's all it takes. And then your users will just be happily anywhere on the internet connecting to your infrastructure. It's great. They made it much simpler. Unfortunately, if you want to support Windows 7 clients, well, you'll still have to go through a much more complex process of setting up the infrastructure. Anyway, it's not on the official objectives, but I want you to be aware of direct access. It's great. It works much easier. And now, if you're using Windows 8 clients and a Windows Server 2012 infrastructure, it's pretty easy to set up. I just talked about direct access and how direct access keeps users connected. It's great. Somebody can be on mobile broadband on their tablet and they'll stay connected to their internal resources. If they, say, go through a tunnel and lose their connection for a while, well, as soon as they get back out of the tunnel and reestablish an internet connection, they'll be automatically reconnected. That's what direct access is great at. Well, when Microsoft came out with direct access, they decided they would also try to retrofit VPN connections to be a little more persistent in this relatively new scenario of these mobile broadband connections that come and go. So with a traditional VPN connection, in this new mobile broadband scenario, imagine somebody goes through a tunnel and they lose access and then they come back out the other side of the tunnel, they get internet access again, and mobile broadband will automatically reconnect to the internet, but the VPN won't. So the user will have to realize that, oh, I have internet access again. They have to go back into their network settings, connect to the VPN again, possibly type their password again. It's quite a nuisance. So what Microsoft did is they updated the VPN client with a technology called VPN Reconnect. So I'll show you how to configure that now. Imagine that you are a VPN user and you have this mobile broadband connection. You get really tired of reconnecting a VPN every time you go through the tunnel on your way to work. So we're going to set it up so that it reconnects automatically. Here's our Windows 8 client computer. I will open up the Charms bar, go into Settings, select the network, and what we want to do is edit this connection. So I'll view the connection properties. So these are the VPN connection properties, and to set up VPN Reconnect, I need to go over to the Security tab here. Now, there are several different protocols VPNs can use. The oldest is probably PPTP. That's kind of a Microsoft invention, though nowadays Macs and Linux will support PPTP as well. L2TP IPsec is based on open standards and it's pretty common, and SSTP is common too. Now, IKEv2 is the only VPN protocol that supports VPN Reconnect. So if you want to use VPN Reconnect, you need to make sure that your VPN server supports IKEv2. Then you need to go into your VPN connection properties and change it from an automatic VPN to IKEv2. Now I'll click the Advanced Settings button here. You can see that by default this mobility checkbox is selected. This is VPN Reconnect. If that's cleared, then VPN Reconnect won't work. The network outage time here specifies how long you can be without internet access and have the VPN automatically reconnect. So by default, if you're going through a tunnel for 30 minutes, when you come out the other side and you get internet access again, your VPN will automatically reestablish the connection. If you want to be able to go all day and not have to set up that VPN over and over again, you can select a longer time. So I click OK there and click OK once more, and VPN Reconnect is enabled. That's all there is to it. This is Tony Northrup for TrainSignal, and I hope you found the lesson both educational and enjoyable, and I'll see you next time.